We're going to talk about JSON. I've got to say a couple of things. Probably in my about 10 years of doing stuff for Postgres, the JSON stuff has got more people more excited when they've talked to me about it than just about any development that I've been involved in. Maybe they have some exaggerated expectations, but it certainly seems to be something that people are very interested in and excited by. So here's basically the agenda we're going to follow. We're going to have a quick look at what JSON is, in case you've been living under a rock, and why we might want to use it. We're going to have a quick look at what we've had up till now. Then we'll do a tour of the new 9.3 features. Then we're going to get a little bit technical and look at how you can use the new API to build extra facilities to process JSON in various useful ways. And I have an example that I've worked for this presentation of a requested feature. So it's not just a toy. And then we'll look at a couple of other useful JSON processing extensions and have a quick wrap up where we talk about what we might do in the future. So that's quite a lot to get through. Let's get to it. JSON is a data serialization format. It's very lightweight. People like it because it's human readable. Probably these days that's not something that is quite as important as it used to be, but back in the days of where there were data serialization formats that were not human readable, it was actually kind of, which were quite prevalent, this was a kind of a big deal. It's becoming pretty ubiquitous, the use of things like Node.js and Ajax and things are making JavaScript pretty much making JSON pretty much the serialization method of choice to send between clients and servers, and it's beating out XML pretty handily in new developments as far as I can see. That's not to say that XML hasn't got a place. I think it does, but we'll debate that some other time. In particular, JSON is simpler and it's more compact than XML, but it only has a relatively simple tree-like structure rather than the multiple aspects that XML has. Here's kind of what it looks like. There are really only two types of composition. You've got these things in curly braces, which are what we call objects, and these things in square brackets, which are arrays. One is more or less the same as a list, if you like, and objects are more or less like an associative array. Those are the only two compositions. The other things that you have are scalars, and they can only be the following: quoted strings, numbers, true, false, and null. That's all you get. There's nothing you can add on to it to add on extra types, and in particular, there are no date time types. Many JSON processors only handle numbers in certain formats. That can possibly be a problem for Postgres because, of course, we have arbitrary precision numbers. However, the JSON spec itself contains no limitations on number format. We can have an arbitrarily large number of digits in a number. The JSON spec itself is basically purely syntactical and says nothing about implementation of processes. You'll notice that in this thing, the date field I've got here is in a string. The JSON has no idea that that's actually a date. Okay, so why use it? Well, because everybody's going that way, and we like to play nicely. in the playground, play with everybody, talk the languages that they're talking. It's understood in browsers. It's understood in a large number of languages. Node.js is very hot at the moment and getting hotter. Most things don't need anything more than JSON. It meets the needs of most applications. Why not use it? Well, it can be overly verbose. If you have a large number of repeated objects, then field names get repeated. That's kind of wasteful of space. So you need to be careful about it there. Also, it's, as will have noticed in that slide a minute ago, it uses a lot of quote marks. That makes it kind of less fun to read than, say, YAML. And so some people like to use YAML for configuration files rather than JSON. That's a matter of taste, but it does affect some people. It's also, in my view, not suitable particularly for huge objects, certainly not in Postgres. It's useful for relatively small objects. Okay. So up until 9.2, we basically had no facilities for JSON whatsoever. You had to store JSON as text. It was basically a blind blob. Postgres had no idea that the data was JSON. There was no way of getting JSON out of Postgres. If it was stored in a text blob, well, you could pull out the text blob, but you couldn't turn. There was no facility to turn a Postgres record or array or anything like that into JSON. And there was no way to pull data out of JSON. You had to write that yourself. So just before we closed off 9.2, very close to the bell, in fact, Robert Haas said, well, why the heck are we going to go another release where we haven't got any JSON support? Here's a parser, let's build the type. And he produced a fairly good state-based validating parser for JSON. As soon as I saw his email, I sent him a note and said, well, look, let's add a couple of things to it so that we can actually produce some JSON as well as storing some JSON. And that was pretty much my contribution to the thing. We basically provided these two functions, row to JSON and array to JSON. And you could, but with that, you could basically use those to, and a few other things to get basically any arbitrary, turn the result of any arbitrary query into JSON. But as soon as people started to play with it, they found that there was a lot that they wanted to do they couldn't do very easily. So what's really missing? The first thing that's missing is that those production features are incomplete. There's no provision for dealing with anything that's not a record or an array, and turning result set into JSON can be inefficient, particularly if you have to use array ag. Furthermore, there were no facilities whatsoever for taking data out of JSON. So for that, you would have to use PLv8, PLPerl, or some other programming language. PLv8 works pretty well for this, but it's not everybody wants to run PLv8. Does everybody know what PLv8 is? Yes? No? No. PLv8 is basically a Postgres PL that is JavaScript. It's based on Google's fairly fast V8 JavaScript processor, which is also at the core of Node.js and the Chrome browser and a few other things. And it's pretty cool. You can do a lot of stuff with PLv8. I believe they now have windowing functions, which is ultra cool. Okay, so here's the thing we added. The first thing we added was a function called toJSON, which you could give literally any data value for, and it would turn it into legal JSON. For instance, if it's a string, it's going to put quotes around it. If it's if it's an array, it will turn it into a JSON array. If it's a record, it will turn it into a JSON record, and so on. And so that pretty much makes the generation features orthogonal. You know, we don't have exceptions. You can turn anything into JSON. You can still use the old functions, but in fact, this function works in place of the old functions. We also have JSON ag with a record, which basically it makes it simpler to turn a record set, and a lot faster and more efficiently than using this expression here, which is what you had to use before to generate JSON from a record set. One of the extra features is that the functions now honor any cast to JSON for a non-built-in type. The reason we didn't do it for built-in types is that we already know how to turn those into JSON, so we don't need a cast for those, and it saves on having to do syscache lookups for a cast for very common things like, you know, text and integers, which we really don't need them for at all. But it is needed for HStore, which is not a built-in type. It's in contrib, and so we've added a cast from JSON, from HStore to JSON, and these two functions, one of which is used for the cast, HStore to JSON, and the other one is HStore to JSON loose. Now the difference is that HStore to JSON treats everything in an HStore as a string, except null. So if it's not null, then it treats it as a string and puts quotes around it, even if it's actually a number or true or something like that. So HStore to JSON loose tries to treat numeric and test the values and see if they look like they ought to be numbers or Boolean values. And if they ought to be numbers or Boolean values, it doesn't quote them. But of course, it's possible to fool it so that you can construct an HStore which is where you really want it to quote something that it doesn't quote. So that's why it's not used as the default cast. But you could change the cast to use HStore to JSON loose if it met your particular needs. And with that, suddenly, before in 9.2, if you had an HStore and you used record to JSON, it produced a horribly quoted, mangled-looking thing. Now it produces basically a JSON object. It looks quite nice. Anything in the record that is actually already JSON simply gets passed through all these functions, so that JSON just falls out naturally. If you've got something that's already JSON, we say, well, we don't want to do anything to that. We're just going to stick it in the right place in the surrounding JSON. Okay. The other part of this is that we've got a whole bunch of new functions to process JSON, to pull data out of JSON, to turn it into different things. And one of the things that we wanted to do, or I wanted to do, was to ensure that we didn't have to ensure that we had some facilities which were extendable, so that we could write more processing functions without having to write things that would reparse the JSON themselves. Basically what we did was to rewrite the parser in such a way that we could actually put some programming hooks in there that you could write yourself, and you could basically hand those off to the parser. The parser would traverse the JSON, call your hooks, and then you could eventually pull your result out of your state object at the end. And in fact, they're kind of like the event handlers. If any of you have ever had to play with XML SAX parsers, you have to have handlers for various events in an XML stacks. So the events here are things like the beginning of an array, the end of an array, the beginning of an array element, the end of an array element. There are in fact 9 handlers. We're going to see about 3 of them used in a second. It makes writing these processing functions relatively easy. We've got about 10 processing functions. Not one of them actually does anything that looks for square brackets or anything like that. All it does is provide these event handlers that manage the structure of the JSON. The tokenizing parts of the previous parser were largely kept. We added on some stuff to handle string values of JSON and de-escape things and that sort of stuff. So we've got some stuff in there to handle Unicode escapes and various other fairly hairy topics. Okay, so all these new functions leverage this API. And there are some operators that call some of these functions which give a slightly more natural style to some of the function calls. Many of them have 2 forms, which will produce values either as JSON or as text. Now, the difference is, for instance, that a JSON string has to have quotes around it, or else it's not legal JSON. But if you want to get at that item for use in some other context in Postgres, or you want to compare it with a Postgres field, you're not going to have those quotes actually stored. So you want to get at the underlying text value. So basically, we give you the option of getting either the JSON type or the text type, depending on what your needs are. Let's have a look at some. The first operator we're going to have a look at is simple. It's dash arrow, which just pulls an array element out of an object. So here we're using 2 as the argument. It's an array. JSON arrays are 0-based. There was some discussion about that, but pretty much every other JSON processor treats JSON arrays as 0-based, like C arrays and so on. And I thought it would be way too confusing to have our JSON processor do anything else, and so we've chosen to treat them differently from SQL arrays. You just have to be aware of that. Or if it's an object, you can give it a key, which is a piece of text, and again, it will pull out the corresponding value. Okay. Here's the text variant. The text variant has got an extra arrow on the operator. And as you can see here, it pulls out just C instead of C in quotes. Okay. And the last bunch of operators are these 2, hash arrow and hash arrow arrow. And basically, their right-hand operand, instead of being a single element, is in fact an array of text. So that lets you construct a path to however deep the value you want to pull out of the JSON is, and pass that to this operator. So here we're going 2 levels deep. We're going into the object, which is 1 level, which is to find the A element, and then inside that, which happens to be an array, we're going to find element 1, which is 7. The hash arrow is the text variant. Okay. There are also for dealing with path constructs. There are these functions, JSON extract path and extract path text, and they operate pretty much the same as those 2 operators that we were talking about, but you don't actually have to construct the array because they take a variadic argument, which means that Postgres will construct the array for you. So you can just pass any arbitrary number of arguments. The only slight wrinkle to that is that if it's a numeric argument, you actually have to quote it or cast it to text. Okay, so here's something sort of slightly radically different. That's an awful phrase. Don't ever do that again. Radically different. Populate record. We're going to, instead of pulling data out of the Postgres particular fields, we're going to take a whole piece of JSON and turn it into one or a bunch of records. And this is pretty cool. If you get given a bunch of JSON from some client and you basically want to insert it into insert the data into a table, you want to deconstruct it all in one hit. You can basically create your type that you want, that you're expecting from your JSON. You call JSON populate record if you've got one of them. If you've got an array of these things, you call JSON populate record set, and it will give you back a whole record set full of these. This was pretty much shamelessly stolen from the HStore populate record function. But I don't think they actually have populate record sets, so no, they don't, because they don't have nested objects. So that was a kind of additional feature. The false here is basically concerned with whether or not you treat the JSON values as text or not. Okay, or you can turn a JSON object into a bunch of key value pairs. And if you do that, that'll turn it into a 2-column result set with names key and value. Or you can just get the keys, and that will. Or you can. There are a couple of things for processing arrays. You can get the length of the array, or you can turn an array into a set of elements. This is kind of like unnest for JSON, except that it only goes one level deep. Okay, so turning to the C API, I kind of gave a general description. So here's what you're going to need if you want to use this. You need a state object. You're going to need some handlers for the various events. We're going to stash these in a JSON sem action object, and we call pg-JSON parse with the JSON and this object, this JSON sem action object, and basically that's all we have to do. After that, all we do is retrieve the result. So the example we're going to do is a JSON typeof function, which people have talked about on the hackers mailing list, and which I will probably do as a built-in for PG 9.4. But meanwhile, we can do it here, and this extension is available and working. If we get time at the end, I will demonstrate it for you. And basically, it's just going to return us text which is going to say string or object or array or bool or null. I think those are the things. Yeah. Okay. So to create your state object, in this particular case, all we need to know, we're going to need to stash a lexical the lexical state for use by the handlers, and we're going to have a JSON token type, which is going to let us format the result. That's all we're going to need. So we're going to need. We only need 3 handlers because every legal JSON must be one of these. It must be an array or an object or a scalar. Can't be anything else. Okay, so we have events for the start of an array, we have an event for the start of an object, and we have an event for when we've hit a scalar. We're going to have those 3 event handlers, and that's all we're going to need. Here are 2 of them. They're not very big. All they're going to do is at the start of an array we're going to say, okay, are we at the top level? Is the Lex level 0? If it is, then we're going to we're going to say that the result is an array, JSON token array start, in fact. Similarly for object, if we're at the outermost level, the result is going to be JSON token object start. And finally, if we're in a scalar, well, the scalar event handler actually gets handed a token which represents the type that it is, because it could be a string or a number or something else. So we're actually going to stash that value in the result as well. Believe it or not, we're almost done. Here's the code that pulls it all together. We get the argument. We set up our state variable. We set up the semantic action object and the lexical analyzer. Stash all this data away and call pgParsJSON. And now the code actually, since I wrote this, I changed the function, so the code you'll see on Bitbucket doesn't actually do that. It contains a switch statement that basically, so instead of this token to type function, it's basically inlined, and it just basically sort of says, well, if you've got this function, this token type, return this string. If it's this token type, return this string, and so on. But that's all you need to construct one of these handlers, one of these processing functions. So that's a very simple example. What could we use it for? We could use it to transform JSON into pretty much anything. In fact, the original use case that I used to work through the various wrinkles in this API was an XML transformation to turn JSON into arbitrary XML of with various parameters. And I still have that sitting around that I might publish at some stage. But the possibilities, as you can probably see, are fairly considerable to provide anything you need to process JSON. For instance, somebody was talking about changing JSON populate record the other day so that it handled nested objects. Well, they might be able to change the core function, or they might be able to write a new one with new handlers. But nothing that you write that is going to process JSON will need to touch the syntactic elements of the JSON at all. All you will have to do is handle the various events and the various values that come out of the parser. And getting those right is actually hard, so that's actually a very good thing. It means you can write these things very much more quickly. I was able to put this together in well under an hour for this little type of function. And I was able to know that it would be correct. Okay, there's a couple of other useful, we're running well ahead of time. A couple of other useful modules which I've developed in the last year or so for processing JSON. In fact, for generating JSON. The first is JSON build. Well, actually, the first one I created was JSON object, which basically takes an array of text and turns it, which can be 1 or 2 dimensional, and turns it into a JSON object. And that was kind of based on the HStore facility, worked in a fairly similar way. But JSON build is kind of more interesting because it lets you build up JSON of arbitrary complexity. If our normal generation functions produce JSON in a pretty regular format, because after all, a Postgres result set is a fairly rectangular object. But if you want to build up if you want to have some some tree structured data, then this is the sort of thing that you can use, which is kind of interesting. There are two functions in it. One is build JSON object, and the other is build JSON array. And basically, they just take any arbitrary number of arguments and construct these things for you. Now, you can call these nested, because again, if either of these encounter anything that is actually already JSON, well, they just pass it through. So you're not going to be in danger of escaping something that's already been fixed. So you can have things like this. And you can see that there's some nested stuff there, and then we've got select row to JSON and some result set there. And it constructs this JSON tree here for you, and it's all legal JSON. And that's going to be kind of useful for people like a friend over here who was passing JSON back to browsers and things like that with arbitrary tree structured data and that sort of stuff. And we at PG Experts, we had a client who needed precisely that feature. JSON object is as I said, is pretty much like the HStore thing. Here's how it works. Okay. Hello. And that's where you get them from. They're also, I think they're both on PGXN. So if you use PGXN for installing your extensions, you can get them from there. All right. So, what is the future of JSON in Postgres? Possible binary representation. The Theodore and Oleg from Russia have done some work on creating a format for a nested HStore object, and we had some discussions at PGCon about using that for to represent JSON. The reason is that it's going to be a whole lot faster, particularly because, as you saw, in order to pull data out of JSON, we're having to reparse the JSON. And if you're doing that every time, it actually slows you down. It's kind of just a function of the format we use. What we would actually like to be able to do is to do this in such a way that it doesn't require rewriting all the existing data pages, so that we would actually like it to be PG upgradable, which means we need to have the data starting with something that isn't going to be legal JSON, so we're going to know if it's actually stored in binary format or not. And there were some issues. I'm waiting to hear back from them. That's certainly something that is worth looking at. One of the things that I've been worried about is whether or not that's actually a good model, because as we mentioned before, JSON can be a bit verbose because you're repeating field names all the time, and we might actually be better off creating a dictionary of strings that are used in the JSON, and then storing the structure completely separately with references into that dictionary, so that repeated strings were only stored once. That's something I've only really just started thinking about. So I think there's a deal more work to do and a deal more thought to be given to this subject. There's also the possibility of using this as a sort of a general document store a la Mongo. The trouble is that right at the moment, if you change a any part of a datum in Postgres, you rewrite the whole datum. Now that's not quite true of large objects, but on the other hand, large objects have a fairly cumbersome API. So we really need to get around this problem of how to deal with structured data in such a way that we can change parts of it, but then we would need to version parts of it, or all the parts of it, so that they would each have their own transaction IDs and all this sort of stuff. So it gets to be fairly hairy. But right at the moment, I would certainly not advise using the Postgres data type for very large data objects. In theory, we can go up to a gigabyte, I think. You wouldn't want to. I wouldn't want to. Okay, so basically the work that I did on 9.3 work was sponsored by Heroku. Thank you very much to them. As always, they are very good to us. And other work was sponsored by some PG Experts clients of ours and also by IVC. And they sponsored those other utilities. So that's all I have. I'm a little early. Are there any questions? Yeah. A gigabyte. I think it's a gigabyte. Yeah, I mean, but then how big is whatever it is that corresponds to your ID? That's for a single datum there, I think. Yeah, yeah. But I mean, if you treat Mongo as, Mongo in theory is the whole thing is a single document store, basically, isn't it?
So what's the limit? Is there a limit for a single document?
Well, the limit for a single JSON datum is 1 gigabyte. But you wouldn't, as I say, you wouldn't want to process that. If you, it depends what the sort of objects you're storing are. Let's say you're storing, a typical good case would be storing web session objects. These are typically not very big. You might have a shopping cart with a few items in it, and some session identifier, and some other information. Probably a bunch of tracking cookies and stuff. But you're talking kilobytes, basically. Not a problem. Probably even megabytes, not a problem. Tens of megabytes, hundreds of megabytes, then you might start getting issues. Yeah. Yeah. For data that size, it's fine. But let's say you want to store it. Somebody talked about storing a whole history, weblog history in a single JSON datum. This, all right? Yeah. Okay. Right. So that's the sort of thing I'm saying don't do. And I'm not sure that we'll ever be able to do it. But we certainly can't do it sanely now. Anybody else? Yeah.
So you said you're waiting to hear back from the rest of the
Yeah. I haven't heard. No. But on the other hand, unfortunately, we have a relatively small window in which to. I mean, this is now the middle of September. We probably have 2 to 3 months to get something done, or else we'll miss the boat for 9.4. So there is not much time. Yep.
So I have a question about JSON extract path. Does that throw an exception if the path does not exist? If parts of the path don't exist?
No, it returns null.
So you might have an element that was null and you would get that. I was wondering if you could use it to validate the internal structure of the JSON. Well, no, I'm talking about do you want to require this object as
Because that addition where he said XML code is
Well, if you get it out as JSON instead of as text, then it will give you back this. If there's null in there, it will actually give you back the string null.
yes.
Whereas if the path doesn't exist, it will give you back a SQL null.
So you could.
Yes. Yes. But I mean, if that would be actually a case for writing an extra processor using this API to say, okay, we're going to pass in some structure, which might in fact itself be JSON, and say, well, it's got to match this structure in various ways.
Have a record object display
Yeah.
browser.
Right.
And know that actually you're receiving from the browser is one of these objects, or you're sending to the browser is one of these objects.
Mm. Yeah. Yep.
one more thing. Maybe you know why the shortcut accesses the dash arrow don't seem to work in PostgreSQL. I have to use JSON extract path. I can't use the
It might be a bug. Let's get with me afterwards, and we'll see if we can work it out. It also might be because it might be intercepted by the PLPGSQL parser. But yeah, we'll check it out. Anybody else? Nope. Okay, thank you very much. I mean, would you like to have do you want to see these things in action? I mean, there's nothing very terribly much to show. All right, let's pull up. Don't know. Oh, it's performing right. This my normal PC is in the shop, and this is my old PC, which is running Xubuntu on top of VirtualBox on top of Windows Vista, with 2 gigabytes on a small, slow processor. So we're going to be lucky. This is the machine I developed Parallel PG Restore on. So it's got a lot of history. All right. So we say create extension. JSON type of. Oh. Would help if I used. Whoa. There you go. You can see the validating parser at work there. String. There we go. So if I say 1, it's going to tell me it's a number. 1.5. Why am I saying number here instead of integer or something else? JSON doesn't make any distinction there. Basically, Whether it's got a decimal point or not, it's a number, and that's all it cares about. We could say true, comes back with bool, null, three, it's an array, and it's an object. If we go back to the presentation, where was I? There, roughly there. Yep, so we go. Copy. And see. JSON build. Just like that. That's pretty much all there is to those things. There's nothing magical. This one though is very, very useful in certain cases where you have an application that is expecting arbitrarily complex JSON, and you need to build it up inside the database with some values some values from the database. Josh Burkus, who some of you probably know from PG Experts, was pulling out some of his hair pretty much trying to get this working, and he was constructing this using concatenation and all sorts of other things. And I said, look, I can do better for you than that. Well, okay. Well, let me put it this way. This is going to give us select row to JSON. Well, we'll take this out. Yeah, I'm going to, but we're going to have to change it because it gives us back more than one row. Well, not like that. It can't. But wait on. We can do better than this. So here's one of the new functions. We're going to say JSON ag. Okay? And this is going to be large. So what I'm actually going to do here, instead of I'm going to say limit 10. Okay? And that's, yeah, you see that's an array of objects with rel kind and name in them. Yeah. Yep. A build JSON object is an extension, yes. Well, the point about it is that you can use this in to build up, to add all these other decorations. So JSON ag on its own is simply going to give you this array here. But if you want to add all these other bits and pieces along with that array, then it gets to be much hairier. So basically this lets you build up JSON of arbitrary complexity in pieces. Otherwise you would have to construct a result set that looked pretty much like that, and that's not that easy to do, nor very efficient, because you would have to use array ag and various other things. Okay? So yeah, that's a good question. That was good. a good thing to do to show you how it works. Any more? Okay, I guess we're done. Thank you.